2. Okay, we're back. What we're talking about is tax. And what we're talking about is taxes on producers. That's what we're talking about here, is taxes on the companies. So let's say we're given these two demand. This is a demand function. This is a consumer demand function. This is a supply function by the producers. Now the logic here is that the government. Let's erase this and do this more in terms of. What's the logic here? I've put it in steps here. One is we're talking about a tax imposed on a supplier or a producer. What does that supplier do? That supplier passes that tax on to consumers. Supplier passes that tax on to his consumers. Okay, so therefore he would add this to his supply function, increasing his price. That's why we put the tax per unit in his supply function. Now the consumers really base their decision on price. So what happens as the increased tax function enters the producer's supply function, the price goes up to the consumer. So what do you expect now? As the price goes up to the consumer, you would expect, therefore, consumer demand to decrease. The assumption here is that the state tax that they put on goods sold to the consumer is small compared to the price added by the supplier. So that's why we don't add anything to the consumer term. Most people, when they go out, they don't buy something because of the taxes on it. They buy it because of the price. Sometimes they have a tax day where they decrease taxes, and people do go out and buy more, but that's unusual. So let's use these terms to figure out to figure out what to do with these functions. Okay? Yeah, if you don't have it written down, well, you can always rerun it. So basically, we're going to add a tax function onto the supply curve. All right, so we're going to rewrite this. So we're going to rewrite the demand curve. As P equals 300 minus 2Q minus 1/2 Q squared. That doesn't change. But we are going to change our supply equation. P is now going to equal to 200 plus 10Q. And we're going to add on a T. Okay, T. That's a price per unit. That's units. So T is going to be a tax dollars per unit sold. Make that a nice little T. Okay, so what do we want to know? We want to know what's going to happen at equilibrium. At equilibrium, at market equilibrium, now we had problems like this in QBUS-110. We let the two price functions equal each other. So we have 300 minus 2Q minus 1/2 Q squared equals 200 plus 10Q plus T. Now I'm going to solve this for T. I'm going to bring the 200 over here. Let's see, what am I getting wrong here? I'm going to solve this for T. So I'm going to get 100 here, which I didn't get before. Let's see if I have one of my... this was 900. This was 900. So I'm going to bring the 200 over here. This is 900, right? Right?
Yeah.
That's going to be 700. It's going to give me 700. I'm going to bring minus 10Q, subtract them here. I'm going to get, I believe that was 12. What was it?
Well, it's minus 2.
P1000 minus 20Q.
10.
This was 20Q. The original one I gave you before was 20Q. And minus 1/2 Q squared. That was from the time we did it before.
So it changes here too.
Yeah, and this is going to be 20Q. Sorry about that. So now I'm going to have 10Q, 20Q, minus, it's going to be minus 30Q. And I'm still going to have the minus 1/2 Q squared. Is that 1/2 or 1/3?
1/2.
1/2 Q squared. And that's going to equal a T. So now you have your equation for your tax per unit. But what's your total tax? Well, remember we had total revenue. We had tax per unit. So what is your total tax? Well, it's your tax per unit times the number of units. So that's the total tax dollar to the producer. So we're going to say here, we're going to call it T equals little t Q, much like we did when we did revenue. Tax per unit times the number of units. So let's go on now. And we're going to find T. I keep moving around because I can't find this thing. So what are we going to do? We're going to find T. Big T. So I had that T is equal 700 minus 30Q minus 1/2 Q squared. So big tax is going to be T times Q. So T times Q is going to equal 700Q minus 30Q squared minus 1/2 Q to the third. Now that gives me my total tax burden on my, yes.
Oh, never mind. I'm sorry, go on.
That gives me my total tax burden on my producer. Now, what do I want to do here? Well, since I'm the government, I want to maximize my tax. So my purpose is to maximize my tax. T. So I have to find what? Well, I have to find the Q that maximizes t. Well, let me take the derivative of t with respect to q. And that's going to be 700 minus 60q minus 3/2 q squared. Okay, now, to make this a little bit easier, I know this isn't the problem, I'm going to make this a 1/3. Otherwise, I'm going to wind up with fractions. So we're going to go back and change the original problem to be 1/3. And that's not going to change anything because this number never had a... Okay. And here's the reason I'm doing that. Is because when I take the derivative, I now get just minus q squared. And it allows me to have a much better... Well, when I set this equal to 0 to find a critical point, I am going to multiply. I'm going to have 700 minus 60q minus q squared equals 0. I like positives in front of my q squared, so I'm going to multiply by minus 1. So I'm going to get q squared plus 60q minus 700 equals 0. Now, because I did this last minute, what's happened is this allowed me to get a much better, in the original problem in the book, you had to use the quadratic equation. By making that a 1/3, watch what happens. Q and a Q. Now, how do we get 700? Well, 70 times 10. And I make this a minus, or I make this a plus, right? And I make that a minus. If I did it, q times q is q squared minus 10q plus 70q plus 60q minus 10 times is minus 700. Set these equal to 0. And we cannot sell minus 70 units. So we're going to look at the problem q equals 10.
2 minutes.
This is a critical point. So we want to find out, is this critical point actually a maximum? And let's look at what? How do we find a maximum? Well, we can take the second derivative. So we can take the second derivative of t prime q. We have to work on the first derivative function. So the second derivative would be minus q, minus 60, plus minus 60 minus 2q. If I substitute 10 in here, minus 60 minus 2 times 10 is minus 80. The second derivative is less than 0, which means we are at a maximum point. And we have the t is at a point of maximum taxation.
Now, earlier you changed this. You multiplied by minus 1. Does that matter?
Has no bearing on it because it's a 0.
Okay.
Nope. All I did was I didn't change the function with t in front of it. I changed the function with minus 1, with 0. Otherwise, I would have multiplied this times minus 1. Now, if you don't want to do that, you can. But I find it tough to get real clean factoring when I have a leading negative in my square term. Finished?
Yeah.
Okay.